Yes, dear participants, welcome back after the short break. So we are resuming it. As I told you, let me show my screen, open the screen. Yes. Okay. My screen is visible to you?
Yes, sir.
Yes. Okay. So let me begin with one non-parametric text called chi-square. Chi-square is a test is a very, very popular test being used everywhere. It is a non-parametric test because whenever you are having a data, so I got two levels of data, two categories of data. One data may be ordinal, other data may be, excuse me, pardon me, please mute your audio, please. Yes, thank you so much. Okay, so you got two data. One is a ordinal data, other is a nominal data. Or one is a nominal data, other is also a nominal data. So when you're having a data nominal versus nominal or nominal versus ordinal, you go for chi-square statistical test. Okay, so chi-square test you whether there is a significant association between these two variables. For example, there is a variable called gender, male, female. These are nominal data. Okay. There's another variable called, would you like to watch movie after 12 o'clock in the night? Yes or no. This is another variable. This is a, what kind of variable? This is a nominal variable. So nominal variable versus nominal variable, you frame a hypothesis. There is no significant association between gender of the respondents and whether they watch movies after 12 o'clock in the midnight. This is called hypothesis. This is a non-parametric test. Otherwise, you have one side nominal data, other side you have got ordinal data. For example, one side you have nativity of the respondents, rural respondents, semi-urban respondents, urban respondents. So one side is a nominal data. What is the ordinal data? You're asking them, how good is today's class? Excellent, very good, good, bad, very bad. These are ordinal data. So you want to frame a hypothesis. There is no significant difference between nativity of the respondents and their rating of today's program. So whenever you're having these kinds of data, you can go for chi-square statistics. Okay, fine. I'll just show you how you can run chi-square in PSPP. First, what is the name of data set? Two weight case normal data. So I need to open a file call. Let me open my software. Okay. I'll go to file, click on open. I need to open a file call to weight case normal data. It's a normal data. Okay. Click on open. Data looks like I got two variables. One is gender, which is termed as male and female. I got level of satisfaction that is termed as good, very good, excellent. Fine. This is data. What about the data view? I have collected data from around 40 students. I click on this height show value label. You can see here male 1, 2, 3, 4, 5. 5 males say, I'm sorry. 1, 2, 3, 4. 5 males say it is good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 males say it is very good. And 1, 2, 3 males say excellent. So this is a data. I went and asked 40 respondents how this particular program is. I collected the data. Here, gender is a nominal data. Level of satisfaction is ordinal data. So you need to conduct chi-square test of association. How to conduct it? It's very simple. Go to analyze, click descriptive statistics, click crosstabs. Analyze, descriptive statistics, go for crosstabs. Okay, what are the two variables? Gender and the level of satisfaction. So gender, send it to rows, level of satisfaction, send it to column. After sending the variables, one variable to row, one variable to column, in fact, you are creating a cross table. That's it. Now, what statistics you need? You need chi-square. Just click on this statistics. Click chi-square. If it's not selected already, just click on this button called chi-square. Now, apart from chi-square, you can click this pi and Kramer's V. There's a value called pi and Kramer's V. Just click it and then click continue. Fine. Now, go and click OK. Here is the result. Now, very simple result has come. What is the result? It says that totally there are 40 respondents and this is a cross tabulation. What is a cross tabulation? Male members 5 says good, 12 says very good, 3 say excellent. Female, 12 people say good, 2 say very good, 6 say excellent. It's a cross tabulation. And this is a result. Chi-square test. You can see Pearson's chi-square. What is the value? 11.03. What is the degree of freedom? 2. See, how do they call degree of freedom? Degree of freedom is equal to total minus 1, n minus 1. In case of normal case, no, degree of freedom will be n minus 1. If there are 10 respondents, 10 minus 1, 9 is the degree of freedom. But here you can see degree of freedom is 2. How do they calculate? Row minus 1 into column minus 1. That is the formula. How many rows are there? 2 rows. How many rows? 2 rows. So 2 minus 1, 1. How many columns are there? 3. 3 minus 1, 2. So 2 into 1, 2. Row minus 1 into column minus 1 is equal to degree of freedom in the case of cross tabulation. What is the sig value? 0.004. Please remember, this is very, very important. In all the statistical tests, inferential statistical tests, we are going to take this p-value, this sig value as the benchmark item to decide whether the null hypothesis is going to be accepted or rejected. Maybe a few years before, people used to take this value, 11.03. There is a big table. They'll compare this value with the table value and take a decision. But nowadays, we never refer to any table. We take only the sig value or a p-value, probability value, and based on this value you have to take a decision on whether you are going to accept the null hypothesis or you are going to reject the null hypothesis. It's very, very simple. Okay, good. How to decide? Universally 0.05. 0.05 is taken as a cutoff point. Okay, if the p-value, whatever value you received as a result of your PSPP analysis, if this p-value is less than 0.05, please remember, please understand, please write, take it down. If the calculated p-value is less than the fixed, the standard, international standard value of 0.05, then null hypothesis is rejected. If null hypothesis is rejected, it means that alternative hypothesis is accepted. So what does it mean? In this particular example, the sig value is 0.004. It is definitely less than 0.05. It means that null hypothesis is rejected and alternative is accepted. So what is the meaning? It means that there is a significant association between gender of the respondents and their level of satisfaction with regard to today's class. Fine? Are you getting the point? So we take a decision on whether to accept or reject the null hypothesis based on the p-value, which is termed as sig value here. Okay, that's the first thing. In all parametric and non-parametric tests, we look for the sig value and we'll take a decision. First point. Secondly, they say it is a two-tailed test. Result is given for two-tailed test. See, when you talk about test, there are two different kinds of tests. One is single-tailed test and other is two-tailed test. See, when you are very, very clear with what is your output, you can go for single-tailed test by direction. You know very well that, for example, there's hypothesis. Whether boys are scoring better in 10th exam or girls are scoring better in 10th exam. It is universally accepted that girls are scoring better in 10th exam. So you are going to test one-tailed hypothesis. What is that? Girls are scoring better than boys. This is my hypothesis. That's a single-tailed. What's a double-tailed or two-tailed? Actually, I don't know whether boys are scoring better or girls are scoring better. I don't know. Only after collecting the data, I should check. If this may happen this way also, this may happen other way also. When you're not able to take a direction, you go for two-tailed test. Okay, very simple, no problem. Okay, so here we don't know whether there is an association between male and female or there is no association. We are not sure whether association is there or not. So when you are not able to know the directional hypothesis, you go for two-tailed test. Okay, fine. If you want a single-tailed test, no, very simple. What people normally do is that 0.004 divided by 2. The answer will be the result of single test. Okay, there is a normal way people go for it. Okay? This is a simple example of chi-square test for normal data. What is normal data? We went to 40 people. We asked each and every one. We collected the data from all the 40 people. Based on this data, we calculated. Is it fine? Clear? Chi-square. Now, please understand, James chi-square, I told you something word called pi value, Cramer's value. See, once you know that there is an association between these two variables, even we can find out how strong the association is. See, we have found out that the association is strong enough. We have found out. Okay, we have found out no how the answer is less than 0.05. So there is an association. But how strong the association is, you have to refer to pi value. If it is a 2 into 2 table, you have to refer to Cramer's V value. If it is more than 2 into 2, it can be 2 into 3, 2 into 4, or 3 into 2, 3 into 3, 3 into 4. You can go refer to Cramer's value. In this case, we have 2 into 3, male, female, one side, good, very good, excellent, other side. 2 into 3 table. So you have to refer to Cramer's V value, which is 0.53. 0.53 means what is 0.53? You have to refer to this table to understand how strong the association exists between these two variables. Okay, it is here. 0.5 is here. It says relatively strong. The association between gender and level of satisfaction is relatively strong. This is one example. And second example, weight case frequency data. I'll go for weight case frequency data. See, I go to file, I go to open, I go to weight case frequency data, I say open. Here things are different. You can see here, no? Data view, I click on this show value. You can see here. See, whatever data I had in the previous file, I counted and the total count is written here. Okay, male, good, 5 people. Male, very good, 12. Male, excellent, 3. Male, female, good, 12. So instead of typing the data individually for every respondent, I counted the frequency for each and every possible pair. I have written the answer here. So whenever you are having this kind of frequency data, you can conduct chi-square absolute no problem. But before you conduct chi-square for this kind of frequency data, you need to do one more thing called weight cases. What is that? Weight cases. How to decide weight cases? Very simple. Go to data menu. In data menu, there's an option called weight cases. Go to data, click on weight cases. What is a weight? It is based on a variable called frequency. See, by default, it is like this. Do not weight cases. Now I am going to select the variable called frequency. I'll send it to this weight case option called okay, 1 minute. Cancel. Weight cases. 1 minute. Do not weight cases. Okay. Okay. Can see now the bottommost portion of my software shows that weights off. Weights off. That means I have not selected any variable to be given any weight. Okay. Yes. Now I'll go to data. I click on weight cases. Here I select the variable and I say frequency variable. Say weight cases by frequency. Here what I want to say is that I tell the software that I have not collected the data from each and every individual and presented here. Instead, I collected the data, I counted the frequency, and you need to calculate chi-square based on this particular variable called frequency. Okay, fine. Say okay. You can see here now weight by frequency. Okay. Once this is done, no, now you go to analyze, descriptive statistics, go to crosstabs. What are the variables? Gender, then level of satisfaction. Go to statistics. You need chi-square value. You need Cramer's V value. Click on continue. Say okay. Now we'll go to output. I just go to output. You can see here the result of the table. You can see here the cross tabulation, chi-square value, Pearson value, degree of freedom, and sig value. Do you think both are same? Yes. Whether you are having the data individually, or you are having the frequency data, whatever way you have data, you get the same response, same way of getting the interpretation for the table. Okay, Kramer's value 0.53, both are same. What I want to say is that whether you are having the data this way individually or whether you are having a frequency data, you can calculate chi-square, absolutely no problem. Okay, yes, I'll give a small example. Go to file, I say open. There's a file called political party versus neat opinion. Okay, I say open. Here you can see there are three items. One is go data view, I show value. You can see here political party. So I got two political parties, first party, second party. Okay, and I asked them one question whether you are for NEET, whether you say NEET is required, or you say NEET is not required, or you say that no opinion. Okay, you have got three options. Okay, my hypothesis, there is no association between the political party of the respondents and whether they are for or against or they don't have any opinion about the NEET examination. This is not my hypothesis. Here, political party is a nominal variable, and whether they are for or against or don't know, that is also a nominal variable. You can go for now chi-square statistics. Here, instead of individual answers, I am having something called frequency. It is a frequency-based chi-square calculation. Now, I have to decide what is a variable to be weighted upon. What is the variable? Frequency 2. Just go to data. In data, weight cases. In weight cases, it is already taken up. Frequency 2. Good. Say OK. Now, you can see here weight by frequency 2. Now, I have given proper weightage. Then go to analyze. Click on descriptive statistics. Click on crosstabs. In crosstabs, select political party one side, opinion another side. Click on statistics, chi-square and Kramer's V value. Click on continue and then click OK. Now let us go and see the results now. It's a result. First, there's a cross tabulation. First party, 78 are in favor of NEET, 30 are against NEET, and 12 don't have any opinion. Second party, 13 are for the NEET, 50 are against the NEET, and 12 are not having any opinion. It's a cross tabulation. Okay, fine. Chi-square says that Pearson's chi-square value is 43.35, degree of freedom is 2, and SIG value is 0.000. As I told you, 0.05 is the international standard of p-value. We are comparing it. If the calculated p-value, it is what is the calculated p-value? 0.000. If this is less than 0.05, is it less than 0.05? Yes, it is less than 0.05. It means that null hypothesis rejected and the alternative is accepted. It means that there is a significant association between political party of the respondents and whether they are for, against, or don't have any opinion about the NEET examination. Clear? So this way you can conduct a chi-square test and you can write the interpretation. Then what about the how strong the association is? This 0.47. What is 0.47? 0.47 means the association between these two variables is relatively strong. Fine? Relatively strong. This is what you write as interpretation for chi-square statistics. Okay, chi-square is a non-parametric test. Whenever you're having one ordinal and one nominal data, or one nominal and another nominal data, you can go for chi-square statistics. Clear? Okay, fine. Now, let me go next one. There's something called chi-square goodness of fit. See, you have collected the data from various respondents. After collecting the data, you want to confirm the observed data with already fixed standard. See, for example, you know very well that nurses, female nurses are everywhere. And if you happen to see from which states all these nurses are coming to what means, for example, see, for example, you go to one foreign country, maybe Singapore or Malaysia, nurses are working. See, people have done a lot of studies and they found out that the people from North India, especially from Tamil Nadu, Andhra, Kannada, Kerala, so they are maximum nurses are from these states. And when they are analyzing state-wise, they come to understand that 10% of nurses are from Tamil Nadu, 5% are from Andhra, 10% are from Karnataka, and 10% are from Kerala. Remaining 75% are from Kerala. That is a ratio they found in some international studies. Okay. Now you are doing a study and you want to decide whether whatever data you are having in your hand is coinciding with the internationally found out ratio. What is the internationally found out ratio? If there are 100 nurses, 10 are from Tamil Nadu, 5 are from Andhra, 10 are from Karnataka, and the remaining 75 are from Kerala. This is what many studies have found out. You want to find out whether your data is also fitting into this ratio or not. Okay, fine. Are you getting the point? Have you got the idea? What kind of, so for example, you are going to a Kendriya Vidyalaya school, a central government organization. If you go there, you can find out of the people, those who are working in Kendriya Vidyalayas in Tamil Nadu, maybe 60% are from Tamil Nadu, 30% are from Kerala, remaining 10% are from North India. This is what normally we find. You want to check whether your data fits with this fixed proportion or not. For this, you can go for chi-square test of goodness of fit. To what extent your data is fitting with this particular standard or not. You can go for this. Okay, for this, I'll go for a data called chi-square goodness of fit, nativity of nurses. Okay, I'll just minimize this. I minimize this data too. Okay, I go to file. I'll go to open. I say nativity of nurses. I say open. You can see here, data can see here. I got nativity, Tamil Nadu, 24 respondents, Andhra Pradesh, 11 respondents, Karnataka, 20 respondents, Kerala, 145 respondents. So Tamil Nadu, Andhra, Karnataka, Kerala. Now I want to test whether my data is coinciding, whether my data is coinciding with what data? With the proportion 10 is to 5 is to 10 is to 75. It is fitting or not. How to do that? Please go to analyze. In analyze, go to non-parametric. In non-parametric, go to chi-square. So chi-square is available in two places. If you are going to analyze descriptive statistics and crosstabs, that is for test of association. If you are coming to non-parametric, if you are clicking chi-square, that means it's a goodness of fit. Okay, yes. Now, what is the variable you're going to check? Frequency 5. Select frequency 5 and send it across the test variables option. Here, you need to type the values. What are the values? 10%, add. Then comes Andhra 5%, okay. Karnataka 10%, okay. Kerala 75%. What is my ratio? 10 is to 5 is to 10 is to 75. This is an internationally accepted ratio. I want to check it. Say okay. Now, let us go to output window to check. And see here now, this is my data. 11 observed, expected. And value observed, expected. Observed, expected. Observed, expected. Okay. We observed 11, we accept 20. We observed 20, we accept 10. We observed 24, we expected 20. We observed 145, we expected 150. Okay, fine. That's what they get. Then just below that, you can get the answer. What is the answer? Chi-square is 15.02. Degree of freedom is 3. What is sig value? Sig value is 0.002. Sig value is 0.002. 0.00 means it is less than 0.05. That means you have to reject the null hypothesis and you have to accept the null hypothesis. What is the accepted null hypothesis? The accepted null hypothesis is that there is a significant difference between the data set what you have and the internationally accepted data set. Fine. That is how you can. So chi-square can be used for two purposes. One is to test the association between the variables, and the other is to test the goodness of fit. Okay, fine. Now, let me move on to next concept called means. Okay, based on the mean, we are having three different kinds of tests. One sample t-test, independent sample t-test, and paired sample t-test. Okay, see one sample t-test, no, just like chi-square test of goodness of it, you can run one sample t-test. See, for example, you're going to a college, You collect the blood sample of around 1,000 college students, and you're checking what is their hemoglobin level. Fine, your calculator. Okay. Now, international standard says that if you are having for women, if your hemoglobin level is 13 gram per square percentage, it is accepted. That means your health is okay. And if it is less than that, no, you are having some iron deficiency in your body and you are prone to anemic. That's what they say. Now, what I did was I collected data from some college students, some college girls, blood samples. I checked their hemoglobin level. Now I want to see whether this my data is coinciding with the international standard, or my sample's hemoglobin level is less than or it is more than the actual standard. I want to test. Okay. So what is the data set? What is the data set? T-test. Okay. There's a file called T-test. So let me go to file. I say open and I'll go to data set called T-test. I say open. Okay. Now data has come. You can see here data view. First, the hemoglobin level. I collected data from 15 girl students. I collected and found out the hemoglobin level. I want to see whether this is in accordance with the international standard, or my sample population, my sample students are having less than the expected level of hemoglobin level. Okay. I go to analyze, go to compare means. In compare means, go to one sample t-test. You go to one sample t-test. What is the variable to be tested? I have test hemoglobin level. Click it. Fine. What is test value? Test value is 13. Internationally accepted hemoglobin level for women population is 13. Just type 13. Say okay. Now let us go to the output. Can see the output now. The output says that hemoglobin 15 respondents are there. What is the mean score? 10.27. What is the mean score? Only 10.27. What is the internationally accepted mean? The hemoglobin level 13. So they should have at least 13 mean score of 13 or more than 13. But hemoglobin level of my respondent is only 10.27. It means that it is less than the expected level. Okay. You just come down. You can see here the t-test there shows the value of t value, then degree of freedom. 15 respondents are there. So 15 minus 1, 14. 14 is degree of freedom. This sig value, what is sig value? 0.000. What is the mean difference? Mean difference is 2.73. What is the expected hemoglobin? 13. Okay. What is the mean hemoglobin of my sample? 10.27. The difference is 2.70. This is mean difference. Sig value is 0.000. It is definitely, it is less than 0.05. That means that null is rejected and alternative is accepted. It means that there is a significant difference between the mean hemoglobin level of my respondents and the internationally accepted standard. In fact, it is less than the mean value. That means that the hemoglobin level is not up to the expected standard, and my sample students are having some kind of deficiency of iron level in their blood. That's what we should understand by this one sample t-test. Okay, fine. Then comes independent sample t-test. See, independent sample test means you got two variables, one independent variable, one dependent variable. And independent variable can be either nominal variable or ordinal variable, and dependent variable should be numerical variable. For example, I'll give an example. What is the example? See, we have got drivers, okay, those who are driving the Gaudi in the night time and those who are driving the Gaudi in the daytime. So two groups are there. Two groups of drivers, those who are driving in the night time, those who are driving nighttime, daytime. So these two groups are called nominal data. Two groups, nominal, one for nighttime, two for daytime. It's a nominal data. What is a dependent variable? Errors, number of accidents they committed. Number of accidents means I committed 5 mistakes, you committed 10 mistakes. So number of mistakes is given in numerical form. It is a dependent variable. What is independent variable? Whether they are night drivers or day drivers. What is the dependent variable? Number of accidents they committed. So one is the nominal data, other is the numerical data. Is it fine? Good. Now, what is the hypothesis? There is no significant difference between night drivers and day drivers, and the number of accidents they commit. This is what my hypothesis. Okay. In this case, you'll go for independent samples t-test. Okay. I told you before you run any parametric test, you have to check whether the data is in numerical form. Yes, our case data is in numerical form. Number of accidents committed 9, 10, 8. These numbers only. First condition is fulfilled. What second condition? You should see whether the data is normally distributed or not. The data is normally distributed, you can conduct parametric. The data is not normally distributed, you can conduct non-parametric. What is a non-parametric equivalent of independent sample test? That is called Mann-Whitney U-test. Mann-Whitney U-test is a non-parametric test. When the conditions required for t-test are not fulfilled, you need to conduct non-parametric test like Mann-Whitney U-test. Okay, fine. Now let us check. How to check it? Go to Analyze. Go to Non-Parametric Statistics. Click on One Sample Case Test. See, one sample case test is used to check whether your data is normally distributed or not. Okay, just click on one sample case test. There, what is the variable to be tested? Number of errors. Send it across. And what kind of distribution? You have to check whether data is normal or not. I selected normal and say okay. Then let us go for the result. The result is here. You can see here that errors, mean, standard deviation, sig value 0.941. Please understand, whenever you are testing this one sample case test, the p-value should be more than 0.05. If the value is more than 0.05, it means that the data is normally distributed. If the answer is less than 0.05, it means that data is not normally distributed. Please understand, make a note of this point. That means whatever sig value you get here, this sig value should be more than 0.05. If it is more than 0.05, it is understood that the data is normally distributed. In our case, it is more than 0.05. So we accept the data is normally distributed. So I can go for independent sample t-test. How to run it? Go to Analyze. Click on Compare Means. Click on Independent Sample t-test. What are the two variables I test? Select the errors, dependent variable. Send it to test variable box. Select the driving time, night time or daytime. Send it to grouping variable. So here, dependent variable. Here, independent variable. I got two groups. I need to define the groups. I need to tell the software, one stands for nighttime driver, two stands for daytime. I need to define it. Just click on define groups and click one here for group one, group two. I got two groups. Group one, I coded as 1. Group 2, I coded as 2. Fine, clear? Yes, say continue. I have defined the groups. How do I know? It's here, no? Driving, 1, 2. 1 means nighttime. 2 means daytime. I have clicked. Then say, okay. That's it. You get the results now. I go to output window. You can see here. First they say statistics. Nighttime, 6 respondents. Mean errors. Okay. Mean for the accidents they committed. 8.567 nighttime drivers. Daytime drivers, 5.75. Just by seeing this, we can understand there is a difference between the accidents committed by nighttime drivers and daytime drivers. Nighttime drivers are committing more accidents than daytime drivers. But this is to be accepted statistically. This is to be proved statistically. How can I do that? Please look at the table below. Independent samples t-test. Here, first part of the t-test is 11 is test for equality of variance. So I told you for parametric test, one is numerical data, and secondly, test of normality, and thirdly, you should find out and ensure that variance between the groups is almost equal. Which groups? Two groups are there. Nighttime, daytime. Both nighttime and daytime drivers are taken from the same population. So we are assuming that the variance between them may not be so much. Okay, they have almost equal variance. That is the assumption. How to check this assumption? Here you can answer Lebanese test for equality of variance. Look for the answer given below sig value. The sig value should be more than 0.05. If the sig value is more than 0.05, it means that the data is having equal variance. Is it okay? I'm clear? Yes. In our case, the answer is the sig value is more than 0.05. If the answer is more than 0.05, then you can look at the answer given at the first row. What is the first row? Equal variance assumed. Suppose, so the answer is less than 0.05. So what shall we do? No problem. You can look at the answer given at the second row called equal variance not assumed. So which row answer you should refer to depends on whether this sig value, this test for equality of variance sig value, whether it is more than 0.05 or it is less than 0.05. In our case, it is more than 0.05. That means that equal variance is assumed. So you have to look at the answer of the first row. Let me look at the answer first row. This is a t value, degree of freedom. What is sig value? 0.001. Definitely, this is less than 0.05. It means that null is rejected and alternative is accepted. It means that there is a significant difference between night drivers and day drivers and the number of accidents they commit. Fine. So that is the conclusion. But apart from this, inferential statistics gives you one more option. You can see here, no, 95% confidence interval of the difference, lower level, upper level. It says that, see, if you take the entire nighttime drivers, entire daytime drivers, entire population, normally what you do, you have a population. In the population, you take only a sample, you test it, you come to a conclusion. So instead of doing this, if you are collecting the data from your entire population, this t-test tells that the mean value, the number of mistakes that they commit, that may differ between 1.52 and 4.31. So this is a population figure. Okay, based on the data collected from just 14 respondents, t-test projects the data is going to be collected from the entire population. Then what would be the mean accidents of the entire population? The population mean may vary between 1.52 and 4.31. So that is what two independent samples t-test is all about. I think I'm clear. And thirdly, you got paired sample t-test. What is paired sample t-test? Same set of respondents are attending first test and they're attending second test. Say, for example, you take 10 students, you conduct one test for them on English grammar, okay? And you see how many marks they get, you make a note of it. And then for 10 days, you teach them English grammar. After 10 days, again call same 10 fellows and you conduct test. You see how many marks they score now. You compare whether your teaching method, your this extra coaching has resulted in increased marks. Is there any difference between marks scored by students before your coaching and after your coaching? Before treatment, after treatment, how is the pressure, blood pressure? How is the sugar level? Before treatment, before taking tablet, after taking tablet, how your sugar level is increasing, decreasing. So whenever you're comparing these kinds of pair, same respondents before and after, you can go for paired samples t-test. In my case, I got two options, AM, PM. That means that I got some 10 students. A teacher is conducting mathematics examination for students in the morning hours. As soon as the teacher enters the class at 9:30, the teacher conducts the maths exam. What is the score of students in the morning? And after 2 or 3 weeks, next test, she's conducting in the afternoon, especially when children come back to the class after having heavy lunch, after lunch, immediately after lunch, test is conducted. So, same set of students, how many marks they scored when they were writing the examination in the morning, and how many marks they were scored when they are writing the examination in the afternoon. Is there any significant difference between these two scenarios? Fine. In this case, you can go for paired samples t-test. Paired sample t-test. Okay, how to go about? click on analyze, go for compare means, there go for paired samples t-test. Analyze, compare means, paired samples t-test. Okay, fine. Now, what are the variables? Paired sample, first one is morning, send it across. Second one is afternoon, send it across. So now two variables are selected. Now I say okay. Let me go to the output window and see the reply. You can see here. Morning, when the students are writing the examination, the mean marks out of 10 they are writing the examination, the average mark student score is 5.25. But when the test was conducted in the afternoon, the average mark scored by children out of 10 was only 3.75. So just by seeing this mean, no, the difference between these two mean is something like mean difference is there. So, but just by seeing this mean difference, 1.25, 1.50, I would understand there is a difference between marks of the children when they are writing the examination in the morning and in the afternoon. But I should prove it statistically. No, you should prove it whether this difference is statistically significant. I should prove. To prove that, come down and see this table called paired samples test. You can see here morning minus afternoon. The mean difference is 1.50. This is standard deviation. This standard error of the mean. And you can see here t-value, degree of freedom, and our required sig value. What is that sig value here? 0.033 is a sig value p-value. So our calculated p-value is less than the expected standard of 0.05. It means that null is rejected, alternative is accepted. It means that there is a significant difference between the marks scored by the students in the max examinations when they are doing it in the morning and in the afternoon. It means that hereafter teachers should conduct max tests in the morning hour so that children will be able to have more concentration and they'll be able to score better marks. That's what the inference you get from this study. Okay, that's called paired sample t-test. So I have seen, I have told you three things. One is analyze, compare means how to run one sample t-test, how to run independent sample t-test, and how to run paired sample t-test. I think it's clear to you. Fine, good. And all these cases we see, in these cases, one independent variable, one dependent variable will be there, and dependent variable will be numerical in nature, independent variable will be normally nominal in nature, and this nominal data will have two levels. Two levels means boys, girls. Two levels: studied, not gone to school; literate, illiterate; rich, poor. So two levels. The nominal data will have only two levels. Okay. If the nominal data is having more than two levels, maybe 3 levels or 4 levels or 5 levels. For example, you take nativity of the students. Nativity will have 3 levels: rural, semi-urban, urban. You take qualification, UG, PG, PhD, 3 levels. You take designation, assistant professor, associate professor, professor. So this way, whenever your independent variable is having more than 2 levels, you cannot go for independent sample test. Instead, you go for one-way ANOVA. ANOVA stands for analysis of variance. So ANOVA is to be conducted when you are having an independent variable, you are having a dependent variable. Independent variable is nominal in nature, but it is having 3 levels, 3 components, or 4 components, or 5, anything more than 2. And your dependent variable is in numbers. In that case, you can go for one-way ANOVA. What are the conditions, assumptions? Same assumptions. Data, dependent variable should be numerical in nature, and the data should be normally distributed. Equal variance is to be assumed. Then you can go for one-way ANOVA. Is it fine? Yes. Let me see the table. Let this be open. Chi-square, let me close this because we may not need it further. Weight case frequencies, I'll close it because I don't need it for the sessions. Then graphs and means, let me close that window also. I don't need it now. Fine. I got only one window called weight case norm also. I'll close it. I don't need it. I got only one window called t-test. I go to my file. Okay, file, open, I go ANOVA. This is a file called ANOVA.sav. Just open the file, ANOVA. You can see here. So what's the data I have got? I have got type and minutes. What's the type? I click on this value label. I have got two variables. First variable is independent variable. I have divided the participants into three groups. First letter group, last letter group, no letter group. Three groups are there. What is that? For example, we are having some jumbled letter game. Okay. Three groups of students are there. I have given alphabets to them, a group of a lot number of alphabets to each and every group. And for the first group, no, I will give one hint. What is the one hint? From these alphabets, you should frame 10 words. 10 words. And what is the first letter of all the 10 words? I just give a hint. First group. And second group, no, I call them, I tell, you should form 10 words. And this is the last letter of all the 10 words. You take last letter as a clue. They went. Third group, no, I don't give any hint to them. I have not told them anything. I told them, you should form 10 words from this pack of alphabets. That's it. So three group students are there. Students with the one letter hint, first letter hint. Students with the last letter hint. Students with the no letter hint. Three groups are there. This is a nominal data. Three groups of response. Not two. Three groups are there. What is the dependent variable? In how many minutes they are completing the task. Whether they take 4 minutes, 5 minutes, 10 minutes, 20 minutes to form 10 words. Okay. Number of minutes each and every participant takes is noted. So this is a dependent variable. So I got one dependent variable in numbers. I got one independent variable which has got more than 2 levels. Here I have got 3 levels. In this case, I go for one-way ANOVA. What is hypothesis? There is no significant difference between first letter group, last letter group, and no letter group, and the number of minutes they have taken to complete the task. This is what my hypothesis is. Okay, we proceed. Before proceeding, I told you we should test the test of normality, whether data is normal or not. How test is? Go to analyze. In analyze, non-parametric, go to one sample case test. Okay, what is the variable I need to test? Minutes. Select it, send it across, select normal, say okay. Let me check the output. What is the output here? You can see the output here. Okay, what is the output? Minutes, 30 respondents, mean score, standard deviation says SIG value is 0.741. I told you, in the case of test of normality, in the case of test of equality of variance, the p-value should be more than 0.05. It means that the data is normally distributed. It means that equal variance is assumed. In our case, the answer is 0.741. It means that the data is normally distributed. I can conduct a parametric test. Okay, fine. Now, let me conduct parametric test. How to conduct? Go to analyze, click compare means, and go for one-way ANOVA. What is this one-way ANOVA? Here, there are two variables. What is the dependent variable? Minutes. Select it, send it across, dependent variable. Select type. What type? Those who are with first letter hint, those who are with last letter hint, those who are with no hint. Okay, type. Send it to factor. Okay, minutes are sent to dependent variable and the group of respondents sent to the independent variable. Now, I need descriptive statistics. I need homogeneity. What about post-hoc? I don't need any post-hoc now. What about the contrast? No contrast now. I have only this answer. Click on OK. You get the output now. Let us analyze the output now. You can see here now. First comes descriptive statistics. They say first letter. They average, they take 15. They have taken 15 minutes. Last letter hint people, they have taken 24 minutes. Those who are not given any hint, they have taken 28 minutes. Just by seeing the mean score, no, I could understand that there is some difference between these groups of fellows. But I want to prove it statistically. I just come down. I check whether the data is having equal variance. So what to test? Test of homogeneity of variance. In independent sample test, they use the word equality of variance. In ANOVA, they use the word homogeneity of variance. Both are same. What is the answer? Answer is 0.704. As I told you, the answer should be more than 0.05. It means that the data is having equal variance. No problem. We can go ahead with one way ANOVA, no problem. Fine. Let me come down now. You can see here, between groups, within groups, two answers are there. So between groups means what is the significance of difference among these three groups of respondents? That is between groups. What is within groups? Within groups means the error that we cannot control for. See, in status always know there is a error part which we cannot find out. Always there will be error. Okay. So now here you can see the error part is lesser, but our contribution part is more. It is 886. Good. And I just come to F value and come to sig value. What is sig value? 0.000. It means that sig values less than 0.05. It means that null is rejected and alternative is accepted, which means that there is a significant difference between the first letter, no letter, and no hint group, and the number of minutes they take to complete the task. Fine. So we have found out. What I have found out? There is a significant difference among these three groups of people. But we are not able to find out of these three groups, which groups are really responsible for this change. Whether all the three pairs are equally responsible or only two pairs are responsible. For example, we can have three pairs. First letter and last letter. First letter and no letter. Last letter and no. Three groups are there. See, maybe all the three groups are having differences. That is why overall difference is there. Otherwise, only two groups are having differences. Third group is not having a difference. So whatever difference is shown here, it is because of only those two groups, not the third group. Possibilities are there? No. Possibilities are there. For example, if three sets of students are fighting, totally 6 students are there. They are in 3 pairs. They are fighting. So when you are outside the class, you would hear some noise. This noise can be either because of only one pair, or maybe because of 2 pairs, or maybe because of 3 pairs. See, but you know that the noise is from those 3 groups. But really, which group is making noise? You should find out. So to do that, you can go for a further analysis called post hoc test in ANOVA. What's called? Post hoc test. I'll go to analyze. I'll go to compare means. I'll go to one-way ANOVA. In one-way ANOVA, rest. Minutes, okay. Type is okay. Apart from this, I am going to select one more option called post hoc. What is the post hoc? Once you find that the ANOVA value is significant, P value is significant, there's a difference between or among these 3 groups of people, you need to find out which pairs of people are actually responsible for the significant change. To find out that, you go for post hoc test. Okay. See, normally we go for Q key, highly significant difference, a beautiful test. Say continue. So apart from the normal parameters, I click post hoc. I opted for Q key HSD. Okay. See, for example, we have checked equality of variance. No, if equality of variance is not there, no, you can go for Games Howell test. If it is equality of variance is same, no, you can go for this Q key HSD. In our case, it is equal. So I selected Q key HSD test. Click continue. Say okay. Now let me run the output window to check further. You can see here same results. Homogeneous variance, ANOVA. But now I got one more table called multiple comparisons. What are the multiple comparisons? First letter is compared to the last letter. First letter is compared with the no letter. Last letter is compared with the first letter. Last letter is compared with the no letter. So 6 possible pairs are compared to each other. Now you see, first letter and last letter, the value is 0.000. That means a significant difference is there. First letter and no letter, significant difference is there. But last letter and no letter, no, between these 2 groups, last letter versus no letter, the answer is 0.053. The answer is more than 0.05. It means that there is no significant difference between last letter group and the no letter group. That means this pair is not responsible for the overall change. So who is responsible? The difference between first letter and last letter, first letter and no letter, only these two groups have caused the difference. Which difference? This difference is because of only these two groups. And this group, no, last letter and no letter, this group is not responsible for the significant difference. Is it fine? So out of 3 pairs of students fighting in the class, only 2 pairs were making noise, and they are responsible for the overall noise when you are walking on the corridor. Third group did not make any noise, and they are not responsible for the noise that you hear from outside. Fine. So this is a beautiful option in ANOVA. If you find out that there is a significant difference, then you can find out which pairs are actually contributing to this significant change in the value. This you can find out using post hoc analysis. You can try. Okay, that's about ANOVA. Now we have seen independent sample test, one sample t-test, and paired sample t-test. Then we had seen one-way ANOVA. In one-way ANOVA, I told you how to find out the results and how to conduct the post hoc test. I taught you. Fine. Next one, correlation. Okay, see, correlation is a very, very important factor, especially when you are having 2 numerical data. You're having not one, you're having 2 numerical data, and you want to analyze whether increase of one variable is increasing the other variable, or decrease in one variable, whether it will result in decrease in other variable also, or increase in one variable, decrease the other variable, whether there is a positive correlation or negative correlation between 2 numerical variables. See, your salary, your savings, whether is there any correlation between your savings and your salary? If your salary is getting more, if you are getting more and more pay, savings also will be more and more. If you are getting less and less pay, savings also will be less and less. So there will be a positive correlation between these 2 variables. What are the negative correlation? For example, you are going to Kodaikanal in a car, you filled your tank, okay, and 100 kilometers are there from your place to go to Kodaikanal. See, if you are crossing kilometers, no, the number of kilometers and the fuel quantity in your tank, it is having a negative correlation. If number of kilometers are increasing, your petrol quantity will keep on decreasing. This is called negative correlation. So we are talking about correlation. The correlation can be either positive or negative. We are talking only about linear correlation. What is linear correlation? When one variable is increasing, other variable is also increasing. When one variable is decreasing, other variable is also decreasing. Or when one variable is increasing, other variable is decreasing. This is called linear correlation. Fine. Yes. Now, let me check. What is the data set? What is the data set? For correlation and regression. That is my data set. I'll go to File. I'll go to Open. I'll go to Correlation and Regression. I select number 4. I say Open. Okay. Now open the correlation regression file. Now data you can see now. I got 2 items: study time and science mark. How many hours you study in a week and marks you received in your science exam. This is also in numbers. This also numbers. I want to see whether is there any linear correlation between these 2 items. When study hour is increasing, the science mark is also increasing. The study time is decreasing, whether science mark is also decreasing. This is what I want to find out using this bivariate correlation. Okay, fine. Go to analyze, click on bivariate correlation. Go to analyze, click on bivariate correlation. In bivariate correlation, I want to study the relationship between study time and science marks. Okay, it's a 2-tile. Say okay, and let me see the output. You can see the output here. Yes. What is the output here? It says that study time Pearson correlation 7:1. It is a plus value. It means that there is a positive correlation between study time and the science mark. If it is minus here, no, in front of 7:1, it means that there is a negative correlation. It is in a positive integer. It means that there is a positive correlation. And the answer is 0.7. See, correlation, if it is 7, no, it means there is a good correlation. Anything above 7, no, 7 and 7 and above, there is a very good correlation between these 2 variables. But how to prove it statistically? Just see the sig value. What is sig value? Sig value is 0.019. Whether you see here or here, both same answer, 0.019. Is it less than 0.05? Yes. It is less than 0.05. It means that null is rejected and alternative is accepted. It means that there is a significant correlation between study time and science mark, and the correlation is positive. It means that when a student studies for more number of hours, he earns more science marks. When he's spending less time for study, he gets less marks. This positive correlation is proved here. Okay, that's called bivariate correlation. Okay, fine. So once there is a correlation between two numerical data, you can go for something called linear regression. What regression? Linear regression. So regression analysis is used to predict. Whenever you want to predict something, you can go for regression analysis. Normally, people say, when you talk about regression, people say regression equation is there. This is called y is equal to a plus b. That's called y is equal to a plus b. So y is the dependent variable that you want to predict. So you want to predict. Say, for example, 100 students are in your class. You got data about all the 100 students. How many hours they study and how many marks they score in science exam. Okay, you're having data for 100 students. Now, if somebody come and ask, if a student studies for these many hours, how many marks he may get in science, you can predict. How can you predict? Using regression analysis. If your saving is going, if your salary is going to be this much, how much would be the saving of Indian population? How much would be saving of this entire college? So whenever you want to predict anything, you can go for regression analysis. First, we'll see simple linear regression. That is one dependent variable that you need to find out, one predictor variable. And apart from one dependent variable, you'll have lot of variables that will help you to predict this. Either you can have only one variable or you can have two variables. For example, how many marks a science student will get, it can be based on many factors. One is how many hours he studies, is 1 point. How intelligent his emotional intelligence score, his IQ level. What is intelligence score? Based on that. So based on their parental education, based on whether he is going for tuition or not going for tuition, based on the quality of the education he gets in the class. Many factors are there. So you can use many factors to predict one factor. If you're using one factor to predict one factor, it's called linear equation, simple linear equation. If you're using multiple factors to predict one variable, is called multiple regression. Okay, I'll just show you simple linear equation. That's called y is equal to a plus b. Y means dependent variable, that is science marks you want to predict, and a means constant. A means constant, whether whatever may be the factors, this is a minimum mark a fellow gets. There is a constant value. B stands for the variable that you are going to use predict. Okay, B stands which value we are going to use? Study time. You are going to study time. So science mark is equal to constant value plus study hour. That is our equation. Okay, so this equation you are going to get using this simple linear regression. Okay, fine. For example, I go here is study time and science mark. I am going to predict science mark based on study time. Okay, how to do that? Go to analyze, click on regression. In regression, click on linear regression. Go to linear regression. Okay, so what is the thing? What is the dependent variable? Science mark. What is the independent variable? This study time. Okay, what is status you need? Okay, many are there. Just leave it. Say okay. Now you get the answer. Let me check the output. Can you see output here? Model summary. R square is 0.52. It means that R square 0.52 means 52% of variance in science mark is due to study time. Okay. Whatever is contributing to science mark, 52% is contributed by your study time. So it's a good. And ANOVA says that the sig value is 0.019. It means that the model is significant and study time is significantly trying to project the science mark. Study time is trying to significantly project how much science how many science marks a particular student will score. So model is good. Okay, if sig value is less than 0.05 ANOVA test, it means that the model is good, you can use it. And finally, you got constant value, which is placed under unstandardized coefficient B. What is the constant value? 34.41. So whatever may be the factor, a minimum mark, a boy will get 34. Okay. What is study time? 0.74. Study time is 0.74. Now I'm going to use this in the linear equation to project the marks of students. Okay, fine. So let me go to my Word file. I'll show you. You can see here. So for example, there's a student who spent 40 hours. There is a student who spent 40 hours. So I want to project if a student studying for 40 marks, okay, how many marks he may get in science mark. Okay, he spends 40 hours a week. Now, how to calculate? Y is equal to science mark is equal to, what is the constant value? 34.406 plus constant value plus what study time? Study time is 0.745 into what is the hour? 40 hours. 40 into 40 hours. So that answer 63. It means that if a student spends 40 hours a week, he will score 63 marks in the examination. So this prediction is possible in the case of simple or any such kind of equation, regression equation models. Okay, that's about linear regression. Okay, fine. That's about linear regression. Then comes, I would like to talk about an important thing called reliability. Okay. So whenever you collect data, no, you collect many data. For example, you're asking question like how satisfied you are with the present job. Okay, you're asking some 20 questions. You are asking 20 questions about how satisfied you are in a particular job you want to ask. After getting the answer, you want to confirm whether there is an internal consistency. Whether I asked 20 questions, whether all the 20 questions combined together, where they reveal whether the participant is satisfied or not in his job. For example, you go to one particular person, you ask 10 questions about their emotional health. Okay, like that you go to many students and you ask 10 questions about emotional health. Then you want to find out whether there is an internal consistency, whether all the 10 questions taken together, whether they are revealing the emotional health of the individuals or not. To check this reliability, we conduct reliability tests. 3 or 4 different methods of reliability test are there. One popular method is Cronpack Alpha. Cronpack Alpha is a popular method of conducting reliability test. Let me open the file. I go to file. I go to open. I click reliability. I say open. So these are the 13 sentences I use to find out whether students are having internet literacy or not. Whether having internet literacy or not. I want to check whether all the 13 statements together, they tell me whether a particular person is internet literate or not. I want to check this. How to check it? Just go to analyze. In analyze, go to reliability. Analyze, go to reliability. Click reliability and select all the variables. Control A. Click the arrow, select across. Click this particular option. Show descriptives for scale if item deleted. Many models are there. I just selected alpha model, Cronpack Alpha, and say okay. That's it. Now let me see the output window. I can see the result here. Can see the result here. How many items are there? Totally, I have collected data from 265 respondents. How many items? 13 questions. 13 questions I asked. What is a Cronpack Alpha? Cronpack Alpha is 0.82. How to interpret this 0.82? You can see here. Anything between 5 to 6 poor, 6 to 7, the reliability is questionable. 7 to 8, the reliability is acceptable. 8 to 9, it is good. 9 and above, it is excellent reliability. So our answer is 0.83. That means that more than 8 means good. So our reliability is good. There is an internal consistency. All the 13 questions together, they reveal the internet literacy level of the respondents. Fine. You can see here, for every question they have given, what is the Cronpack Alpha if item deleted. By deleting any item, I will never get more than 82.82. So I return everything. For example, Here, I can get information quickly in time. For example, by removing this item, if my Cronbach alpha becomes 95, for example, I will remove this item from analysis, because by removing this one item, my Cronbach alpha will become more than 85, 86, 87, means I will remove this item. But in this case, no. See, you remove any item, the score will not go beyond 82. You can check here. Everything 80, 81, 82 maximum. So by removing any item, I will never get more than 82. So I take all the 13 items, and all the 13 items will be used for my analysis. So that's called the reliability analysis. Very, very important. Fine. Then next 10 minutes, we'll talk about non-parametric tests. What is that? Non-parametric tests. Okay. See, whatever parametric test we studied, for all those tests, there's an equivalent non-parametric test. Already we learned two non-parametric tests. One is chi-square statistics, and secondly, test of normality called one sample KS test. So both are available in the analyze menu. Analyze non-parametric test, you can see. Rest we'll see. Okay, for example, I got data like this. I got two groups of respondents. One group belong to Ramasamy Club. Another group belong to Kandasamy Club. So two clubs of respondents. Some 20 students are from this particular club, and another 20 students are from another club. So both the clubs, they went to watch a drama, Shakespeare drama. After watching Shakespeare drama, they're asked to give a rating for the drama. You can give a rating 1 to 100. 1 means the worst. 100 means the best. 50 means okay. You can give a rating. Rating means ordinal data. So, one side nominal data, I got two groups, Ramasamy Club, Kandasamy Club. Another side, they are rating. They are not giving mark. They are giving a rating. What rating they are giving for the particular movie. This is ordinal data. So, when you are not having the dependent variable numerical form, your data is ordinal nature, you'll go for non-parametric equation. Non-parametric equivalent test you'll go for. Okay, I'll just do that. Go to t-test file. I think it is already open. I open 1 minute. I just close the reliability file. Okay, same way I'll close correlation also. If required, I'll open it again, correlation. Okay, I'll go for t-test. In t-test, you can see club. I'll just click this show variable. Ramasamy Club and Kandasamy Club, two club members are there. The rating they are given. So it is a number. It is a rating. We told them you have to rate the show from 1 to 100. The number you give is a rating. It is not a numerical number. It's a rating. Rating means ordinal data. So we want to find out what a hypothesis. There is no significant difference between rating of Shakespeare's drama by Ramasamy Club members and the Kandasamy Club members. That is what my hypothesis. But here, it is a rating data, ordinal data. So I cannot conduct independent sample test. Instead, I'll go for non-parametric test. Okay, go to analyze. In analyze, go for non-parametric statistics. There you can see here K independent samples. What is that? K independent samples. Whether 2 or 3 levels, you can go for same thing. K independent samples. What is the variable to be tested? I need to test rating 0 to 100. What is the grouping variable? Club. Okay. I have defined the group. Two groups are there. Group 1 and group 2. Kandasamy group, Ramasamy group. Click continue. And you can see what is the test? Kruskal-Wallis. Click Kruskal-Wallis. If you go to SPSS, SPSS provide two tests. Mann-Whitney, if your independent variable is having 2 levels. Kruskal-Wallis, if your independent variable is having 3 levels. But in PSPP, only Kruskal-Wallis is given. So Kruskal-Wallis can be used for both the levels. Whether you're having 2 levels or more than 2 levels, no problem. You can use Kruskal-Wallis. I say, okay. Let us see the results. So I'm in the results section now. You can see here, Ramasamy Club, mean rank. Kandasamy Club, mean rank. Mean score is not given. Mean rank is given. What is the rating? Chi-square value, degree of freedom. Sig value is 0.009. So it is less than 0.05. So what is the meaning? Null is rejected. Alternative is accepted. It means that there is a significant difference between rating of Shakespeare's movie by Ramasamy Club members and Kandasamy Club members. It is at par with independent sample t-test. Am I clear? Yes. And let me go for a paired sample. Candidate 1, candidate 2. For something, for example, we think this way. See, two candidates are appearing for the test, and we have got around 10 interviewers, 10 teachers. They are testing these two students. Same 10 teachers are testing first student. They are giving rating whether this fellow is how good he is for the promotion. Same 10 set of teachers, they are evaluating second candidate and they give a rating how good he is for the promotion. And we want to find out, is there any difference between the ratings of the teachers of first set and teachers of second set? Here, this not numbers, both are ratings. They are rating out of 20. You give a rating for this candidate. Okay, each teacher will give out of 20 what is the rating for this candidate when he is going to appear for the promotion test. Fine. So here both these are ratings. They are ordinal numbers. They are not numerical data. So I cannot conduct paired sample t-test. So I have to go for some non-parametric paired sample test. I just go to analyze, click non-parametric. There, two related samples. Two related samples means paired sample t-test. No, there we conducted. The same we conduct here. Two related samples. What are two items? Candidate 1, send it. Candidate 2, send it. Then I go for Wilcoxon. Wilcoxon is the equivalent of paired sample t-test. If data is numeric, data is normally distributed, you can go for paired sample t-test. If data is not numeric, you have to go for Wilcoxon paired test. Okay, say okay. Good. Let me go to the output window to get the results. You can see here, candidate 1 minus candidate 2, negative ranks, positive ranks. You can see here, sig value 0.028. See, 0.028 is sig value. It says that it is less than 0.05. It means that there is a significant difference between rating of first set of teachers and the second set of teachers. The difference is there. It's called related samples when data is not numeric. Okay, that's about non-parametric. And let me open another file called one-way ANOVA samples. Here, for example, see, what about the non-parametric equivalent of ANOVA test? See, for example, we've got three groups of respondents. Actually, they want to get some relaxation. Okay. And for one group of respondents, we are giving tablets. They're taking tablets. Another group, no, we do some kind of hypnosis. Some kind of hypnosis we do. We try to make them relax. There's another group. We teach them basic yogic exercises by which we are trying to make them feel relaxed. So three groups of respondents are there. This independent variable is a nominal data. The other side, after the treatment, we are asking them to rate, okay, to the 0 to 50. You give a rating. How relaxed you feel now after taking tablets, after doing exercises, how relaxed you feel. Give a rating from 0 to 50. If you give a rating of 0, no, you are not at all relaxed after your treatment. If you are putting 50, no, you are getting a maximum relaxation. So give a rating. It's not a number, it is a rating. Okay. So in this case, no, you cannot go for one-way ANOVA because you have not collected numbers. You are asked them to rate your relaxation level. So in this case, you can go for one-way ANOVA because independent variable is having more than two levels called pill, hypnosis, and exercise. Three levels. You can use crystal valleys for both the levels, both the situations. Just click OK. Let me go to the output window. I see the answer here. What is the answer here? Those who are taking pill, their mean rank is 3.5. Hypnosis, 10, XI is 14.29. It means that there's a difference between the relaxation rating given by these three groups of respondents. Those who are doing exercise, they are given maximum rating, 14, their mean rank. Then comes hypnosis. Then finally comes pill. I want to see whether this is statistically significant. I just come down. I look for sig value. What is sig value? 0.001. 0.001. Definitely it is less than 0.05. It means that null is rejected and alternative is accepted. It means that there is a significant difference between these three different kinds of treatments and the level of relaxation obtained by the respondent. It is called the critical values, which is equivalent to one-way ANOVA. Am I clear? Yes. And see, we talked about repeated samples, no? Paired samples, no? Imagine if same situation is coming into three levels, what to do? See, there are three levels. For example, we have got people, 10 students are there. 10 students are staying in a hotel. You are asking 10 students to test to have breakfast and give a rating 0 to 100 how good the breakfast is. Same 10 students, they're asked to have lunch in the same hotel and they give to give a rating from 0 to 100. Same 10 students, they are taking dinner over there and they're giving a rating from 0 to 100. That's called here it is a kind of paired test, sample test, but here not two, three levels are there: breakfast, lunch, dinner. So I want to see, is there any difference between the students while they are giving a rating for breakfast, lunch, and dinner? If it is so, which food is better than the rest? I want to find out. See, in paired sample t-test, normally we have two groups. Those who are writing, only one group writing examinations in the morning, and the same group is writing examination in the afternoon. Okay. And same 10 teachers are testing first student and they're testing second student. Paired sample only two groups. But here we are having three groups. But what is the response? We are getting the response as a rating, not numbers, rating. Since you are getting the responses in the rating ordinal scale, we cannot go for parametric, we'll go for non-parametric. How to conduct? Go to analyze, click on non-parametric. In non-parametric, go for K related samples. Only two paired samples, go for two related. More than two, go for K related samples. Click on K related. What is the test variable? You need to select, you need to find out breakfast, send it, lunch, send it, dinner, send it. So these are test variables. Okay, I want to go for Friedman. Friedman test is meant for when there are same set of students or respondents are taking part in three different examinations, three different concepts. When you want to check whether is there a difference among them, you can go for Friedman test. Just click on OK. Let us see the result now. You can see here results. Breakfast rank is only 1.50, lunch 2.70, dinner 1.80. It means that they all felt that lunch is better, the best, followed by dinner, and the least rank is given to breakfast. But is it significant? It's come down. See the sig value 0.020. 0.020. It is less than 0.05. It means that there is a significant difference between a rating of students on breakfast, lunch, and dinner. Okay, so even when you are having more than two levels, also can go for this kinds of paired sample t-test. Okay, fine. So this you can conduct. These are the non-parametric tests which you can conduct. Okay, yes, and I think that's what I have today for you all. Now the session is open for question answer, and whatever questions you feel like asking, please go ahead. Questions, please, on whatever studies will be conducted. Any doubt? Kogila, Abhi, Parkavi, Divya, Indumadi, Kurunji, many are there. Any doubt, please? You're most welcome. No doubt? Indumati ma'am, any doubt? Indumati ma'am, any doubt? Okay. Divya, no doubt. What about Gokila Abhi? Any doubt? At least one of you can unmute yourself and answer me whether it is okay. You don't have any doubts? One of you?
Okay, sir, no doubt.
No, but thank you so much. So in case you're not having 1 minute, if you're not having any doubt, 1 minute. And so as usual, I will place the feedback link in the WhatsApp group. You can kindly submit the feedback form.
Good evening, sir.
Please go ahead, please.
Hello, sir.
Yes, ma'am, please, ma'am.
Hello,
Please go
sir.
ahead.
Good evening.
Ma'am, good evening, ma'am. Ma'am, please go ahead with the question. Nirmala, ma'am, please. Nirmala, ma'am, you can ask the question. Nirmala, ma'am, good evening. Ask the question. Nirmala, ma'am, you are unmuted. You can ask the question. Ma'am, question kelunga. Can you explain again? What, ma'am? What should I explain again? 1 minute. Can you explain again? Enna explain pannu, ma'am? What should I explain again? Please tell me. I'll explain it.
Sir, can you explain me again once again that one day ANOVA test used for which category of data, sir, please?
Okay, ma'am. I'll tell you. No problem, ma'am. See, ma'am, you are having two sets of variables. One is called independent variable. Other is called dependent variable. Your dependent variable is in numerical data. You are having numbers as a response you collected. How much? What is your salary? What is your age? What is your savings? All those things. And independent variable you are having. Independent variable is having not 2 levels, more than 2 levels. See, gender, male, female, only 2 levels.
Okay.
Urban,
kind of,
semi-urban,
category of-
rural. Qualification. Yes.
Okay.
Independent variable is having 3 levels. Your dependent variable is having numerical data. In this case, you can go for one-way ANOVA.
Okay. Sir, what in case if I have only Likert scale if I use to collect the data for certain
Okay.
information.
Okay.
So can I able to use the ANOVA test, for example? I have collected sustainable financial practices in banking sector.
Okay.
After implementing sustainable financial practices in public sector banking, what is the performance level? Whether
Okay,
it is
okay.
well in financial level or in other levels, I have used the Likert scale.
Okay.
Can I use ANOVA test for this, or will you suggest?
Okay, ma'am. I'll tell you very, very plainly. I'll tell you open secret here. Okay. See, ma'am, for example, you asked some 6 questions, for example. Okay. You take one concept called financial intelligence, something like that. You asked 6 questions which will test the financial intelligence of the respondents, for example. Okay. And to be more frank, each and every question you ask the respondents to give the answer in the 5-point Likert scale or 7-point Likert scale. Okay. And for individual statement, I told you, you have used 6 statements. You have used 6 statements to understand how intelligent this particular respondents is with regard to financial knowledge. Okay. For individual statements, you have to conduct only critical volleys. You cannot conduct one-way ANOVA because the data is not in numerical form. The data is in Likert scale, which is called ordinal data. Okay. So what we do is that you got 6 statements, no?
Yeah.
You got answers for all the 6 statements in Likert scale. So we are adding the responses of all the 6 statements and you get one figure, no?
Yeah.
First question he made a selected 4. 4
Yeah.
means agree. Yeah. Next question he would selected 1. Very disagree, very strongly disagree. So you add all the 6 statements. Whatever responses are given by each and every candidate for all the 6 questions added. So you get one answer, no? You get one answer, no? What is the heading called? Financial knowledge. You ask 6 questions. You add, go to transform, click on compute. You select all the 6 statements. You compute. Now you get only one score. Now you get one score. One score for one respondent for all the 6 statements taken together. And all these 6 statements are talking about financial intelligence of the respondents. Okay.
Yes.
For this combined score, for this added score, you can conduct one way ANOVA.
One way ANOVA.
Yes,
Okay.
Okay, ma'am.
Okay, sir. Okay.
Thank you
so much, sir.
Thank you so much. Any other doubt? Thank you, Nirmala ma'am. Any other doubt? I'm happy to get questions like this.
Yeah, thank you. Because I'm doing the pursuing PhD. So I use the 6 statement as you said, and like the scale I have collected the data. So that's why I want to confirm before going for.
Sure. See, there's so many people, no, management when they're doing the course, no, they do factor analysis. See, they have got some 20 statements, no, they do factor analysis. All the 20 questions will be divided into either 3 factors or 4 factors. For every factor, no, they add the score. For the added score, they'll conduct one way ANOVA. They'll conduct different sample tests. They do all those things.
Yeah. Thank you so much, sir. It's
Thank you,
very
ma'am.
useful.
Sir, please, sir. Any other query, please? Just like Nirmala, madam, anybody else who wants to ask a question? Okay. So thank you so much for this beautiful audience. See, feedback link, I'll share it in the WhatsApp group. Kindly fill the feedback form before tomorrow 8 o'clock. And tomorrow night, I will post all the certificates in the WhatsApp group. And recordings of both the sessions will be uploaded into my YouTube channel. And I will give links for my YouTube videos also. So thank you so much. Take care. Bye.